So since we're considering the modern structure of the atom, we said the atom has a center, that is where the mass of the atom is located, and it is known as the nucleus. Is that okay? So I have my nucleus here, as stated earlier on. In the nucleus, we have what we call the neutrons and the protons. So we have the protons and the neutrons. So I've labeled here the neutrons, and then here the protons. So the protons and neutrons, they are located inside the nucleus of the atom. Is that okay? And around or outside the nucleus, we have the electrons. And they are present in what we call the shells, or the orbits, or the energy level. So let me indicate here. Here is a shell. So this one is a shell, another shell. So we have only two shells here. Is that okay? The protons in the nucleus, they are positively charged. So I've indicated the charge of the proton here. The protons are positively charged in nature. And then the electrons are also negative charge. So the protons are positive, and then the electrons are negative. So these are negatively charged particles, and these are positively charged particles. The neutrons, they carry no charge. They are neutral particles. So they are neutral particles. Is that okay? So that is the modern ideology of the atomic structure. Now let's look at some terms associated with the atom. So one, before we consider the terms, let's take a typical element. So let's take X as an element. We have something here at the upper side here. I've labeled it A, and then this side here, Z. So that is A and Z. Here is the superscript, and here is the subscript. A for the superscript and Z for the subscript. The A here represents the mass number of the element. The A represents the mass number of the element, and the Z represents the atomic or the proton number of the element. That is the structure of an element. It has the mass number written on the on my left side, that is the upper side, and then the lower side we have the Z. The A is for the mass number, and then the Z is for the proton or the atomic number. Now let's look at some of the terminologies here. I have one, atomic number or the proton number, and it's donated by Z. Is that okay? So you can also donate it by P, proton, P. Is that okay? So Z or P for the atomic number or the proton number. What is the atomic number or the proton number? It is the number of protons in the nucleus of an atom. The atomic number or proton number is simply the number of protons in the nucleus of an atom. So the number of protons in the nucleus of an atom is known as the proton number or the atomic number. For a neutral atom, the number of protons is exactly equal to the number of electrons. So to know the number of electrons in a neutral atom, you can simply indicate it by its proton number. So the proton number is simply the number of protons in the nucleus of an atom, and it's denoted by Z. So in the structure of the elements, anytime you see a variable here, a number here, it indicates the proton or atomic number. For example, let's take an element Na. So this is a symbol of the element, and then I have a number here. This number corresponds to what we have here, the Z, and Z is the proton or atomic number. So what is the proton atomic number here? 11. Is that okay? So the proton atomic number for Na is 11. It has a proton number of 11 or an atomic number of 11. Is that okay? Now, what about the superscript, which represents the mass number? The mass for Na here is what? 23. So the A here is 23, and then the Z here is 11. Now they can ask a question: how many electrons do we have in Na? Na here is a neutral atom. What is a neutral atom? A neutral atom has no charge on it. So So since there is no charge on the element here, it is a neutral element or an atom. Is that okay? So the number of electrons in a neutral atom corresponds or is equal to the proton number or the number of protons in that atom or element. So since we have 11 protons here, so we can also say that we have 11 electrons in the element here. Is that okay? So that is it for the proton or atomic number. Now the second one, I have mass number, or it is also called the nucleon number. Nucleon is a collective name given to the particles that make up the nucleus. A collective name given to the particles that make up the nucleus. And we know that from the diagram I have here, in the nucleus we have the neutrons and the protons. Is that okay? So the nucleus is just the protons and the neutrons in the nucleus of an atom. Is that okay? So I have mass number or the nucleon number. What is this mass number? The mass number is the sum of the protons and sum of the neutrons in the nucleus of an atom. So the mass number, it is the sum of the number of protons and the number of neutrons in the nucleus of an atom. Is that okay? So the mass number is also known as the nucleon number because the nucleon talks about the protons and neutrons in the nucleus of an atom. So in place of the mass number, we can also say the nucleon number. And it's denoted by the variable capital A. Is that okay? How do we calculate for the mass number? We use this relation A is equal to Z plus N. A is equal to Z plus N. What is A? Our A here is our mass number. What is Z? Z is a proton or atomic number. And then what is N? N here indicates the neutron number or the number of neutrons. Is that okay? So the mass number is simply the addition or the sum of the number of protons and the number of neutrons in the nucleus of an atom. And it's also known as the nucleon number. How do we get the mass number? By using the relation mass number is equal to proton number plus neutron number, or protons plus neutrons. That is A is equal to Z plus N. With the help of this relation, we can know the mass number. We can also... Alright, so as I was saying, the mass number or the nucleon number is just the addition of the number of protons or the atomic number plus the number of neutrons in the nucleus of the atom. Is that okay? That is the mass number. So with the illustration here, X is the element, A, that is the superscript, represents the mass number, and then Z represents the proton or the atomic number. Is that okay? So to calculate the mass number is simply the number of protons plus the number of neutrons. So from this relation, we can make each of them the subject. So making Z the subject, Z will be equal to A minus N. And if you try to make the number of neutrons to the subject, N will be equal to A minus Z. So the number of protons is also equal to the mass number minus the neutron number. And the neutron number is also equal to the mass number minus the proton or the atomic number. For example, let's take an element Hg. So let's look at this example. So looking at this example here compared to the elements we have here for the illustration. Now, what does the 200 represent? The 200 represents what we call the mass number. And then the 80 here over there represents the proton or the atomic number. Is that okay? Now, how do we get the neutron number? How do we get the number of neutrons in this element? So from the relation A is equal to Z plus N, as indicated over there, we can simply make the N the subject. So making N the subject, N is equal to A minus Z. So how do we get N? N is equal to A minus Z. A is what? 200. And then Z is what? 80. And then we have 180. So the number of neutrons in mercury with a mass of 200 and then a proton number of 80 is equal to 120. Is that okay? So that is also the mass number, and I said the mass number is also known as the nucleon number. What is a nucleon? A nucleon is just the particles that make up the nucleus of an atom. Is that okay? And don't forget that in the nucleus we have the protons and the neutrons. So the number of protons and the number of neutrons corresponds to the mass number. And since its collective name is the nucleon, it is also known as the nucleon number. So its donation is A. Don't forget that the relation between the proton number, the mass number, and the neutron number is given as A is equal to Z plus N, where A is the mass number, Z is the proton number, and then N is the number of neutrons. Is that okay? I hope you understand. Alright. Now let's consider the next terminology over there. So we have neutron number. What is the neutron number? Simply, it is the number of neutrons in the nucleus of an atom. So the neutron number, the number of neutrons. So number of neutrons in the nucleus of an atom. The number of neutrons in the nucleus of an atom. That is the neutron number. And we can easily calculate the neutron number from the relation we have A is equal to Z plus N. Making the neutron number the subject is simply equal to the mass number minus the proton or the atomic number. That is N is equal to A minus Z. Is that okay? That is it for the neutron number as well. Now the next technology we need to understand here is isotopes. Isotopes. What are isotopes? Isotopes. So isotopes are atoms of the same element. Atoms of the same element with the same proton or atomic number, but they have different mass numbers. Is that okay?